Hi, welcome to Moose in Chemistry. Today we're going to talk about VSEPR models and hybridization. A lot of my students kind of asked me to do a detailed lesson on hybridization, so we're going to get with that. And I've chosen the compound sulfur hexafluoride. So now let's go through and figure out our structure to start with first before we get into hybridization. So sulfur is in group 16, so that means each sulfur has 6 valence electrons. Remember to drop the 1. And each fluorine, which is in group 17, has 7 valence electrons. So we have that. Now what we want to do is find out how many total valence electrons we have for this compound first. So we have 1 sulfur at 6 electrons. We have 6 fluorines at 7 electrons for their valence. So we get a total of 6 valence electrons for sulfur, and we have 42 valence electrons for fluorine. So that's pretty easy. So we add the two together and get 48 valence electrons. Wow, this is great. So far, so good. So now let's go ahead and let's look at our structure here. Let's try to draw a structure. We'll put S in the center because it's the least electronegative. Also, sulfur has 2 open docking ports, which I like to call them, and that makes it kind of easier to say, okay, that's the center atom. So now we want to place our F's around our sulfur. And you don't have to do it perfectly, but that looks pretty good. So now we want to use up 48 electrons. Now remember that 2 dots equals a stick. And these sticks are called sigma bonds. That's called a sigma bond, and we're going to use that later in the lesson. All right, now, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. Oh, that's great. I didn't run out of sticks. Oh, let's see here. This stick somehow got messed up here, so let me fix that stick. And that stick goes right there. I'm not sure what happened there, but there we go. All right, now let's check out the formal charge to make sure that we did this the best possible way. So our formal charge, we'll start with sulfur. Sulfur, remember, everything came in with valence electrons minus non-bonding electrons minus bonding electron pairs, okay? So with sulfur, we came in with 6 valence electrons. We have no non-bonded electrons. They're all sticks, so we get 0. And we have 6 sticks, which means we have 6 bonded electron pairs. That gives us a total of 0 for the formal charge, and that's a good number for us. Let's check out the formal charge of the fluorine. Now, we don't have to do all 6 fluorine. We just have to do 1, so I'm going to pick that one right there. So now, when we look at the formal charge for fluorine, fluorine came in with 7 valence electrons minus 6 non-bonding electrons minus 1 bonding pair. Okay, so that's going to give me a total of 0. So that's good. So let me erase these things right here. Okay, so now everything looks good so far. So now what we want to do is we want to decide, okay, what kind of model do we have here? All right, so the model that we have here, to figure out what kind of VSEPR model, we would use the sulfur. We're going to say our sulfur is our center, so we're going to call that one A. We'll put an X here, 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 and an X here. So that gives me AX6, which is called an octahedral, and the bond angles, that means these angles right here, are 90 degrees. So the bond angles are 90 degrees. Now, let's talk about hybridization. Okay, when we talk about hybridization, and what we're going to do is we're going to erase some of this so we can have, and actually we'll clear the drawings, it would be easier to do, and I'll redraw the sulfur structure so we can do the hybridization. So we're going to clear all drawings here, and all drawings are clear. So I'm going to redraw our sulfur, and I'm going to put our F's around it. Because that was a lot of writing. So again, 2, 4, 6, 8, 10, 12, and then of course we're going to fill in our wraparound dots. And we know that this is the best possible structure, so we don't need to do the formal charge again. All right, now we know that this is an AX6 octahedral. And we know the bond angles are 90. So what is the hybridization? So what is the hybridization? Okay, so what we're going to do is this. In hybridization, you need to know just a few simple rules. A stick is known as a sigma bond. And we call sigma like this. And 2 dots is called a lone pair, and those are also counted. So lone pair of electrons and sigma bonds are all the only thing that we use for hybridization. So now, what is hybridization to start with? Well, hybridization to start with is like, for example, let's take the electron configuration for sulfur, which is, so sulfur is 16, so we go 1s2, 2s2, 2p6, 3s2, and then it'll be 3p4. All right, so now, when we look at this, we're talking about, all we really care about are our valence electrons. So we're talking about S and P's. All right, so now, S only has 1 suborbit, and then P's would have 3 suborbits, and D's would have 5 suborbits, like that. Okay, so now when we hybridize these, we're going to take 1 from S, 3 from P, and actually in this case we're going to take 2 from D. So when we combine this, the hybridized orbital for sulfur is going to look something like this. 1 from S, 3 from P, and then 2 from D. So this would be S, P, 3, D2. All right, if you didn't get that, let me show it to you another way. So let me go ahead and erase this for a moment. I'll erase all this right here, because we already know the electron configuration of sulfur. That's not a big deal. So it's going to take a few moments for me to erase while you're thinking about everything I just said. So there's another way to look at it to make things a whole lot easier to do. So remember that only sigma bonds and lone pair of electrons are hybridized. So again, let's look at our structure right here. All right, we're going to look at the S. Each one of these is a sigma bond. 1, 2, 3, 4, 5, and 6. All right, for the S. So what does that really mean? What that means is this. We take 1 for S, 3 for P, 2 for D. If you add 1, 3, and 2, this all equals 6. So you know that S, P, 3, D2 is the best possible structure for the hybridized orbital because you have 6 sticks going around S. All right, so that's the hybridized orbital for S. So let's look at another one. Let's look at the F. Now the F right here, we'll take this F right here for example, and we're going to go ahead and erase this little arrow here. And we're going to erase these numbers here because we're doing a totally different atom now in the same structure for its hybridized orbital. And all the F's are the same. All the F's look the same. See, they all have 6 valence electrons and then 1 stick. So they all look the same. So I'm going to go ahead and get rid of all those there real quickly. And go ahead and erase this, of course. So now we're going to do the hybridized orbitals for F. So if you look at F, F has 1 sigma bond. And it has 1, 2, 6 valence electrons. But remember, they're called lone pairs. So this would be pair 1, pair 2, pair 3. So again, we have 1 sigma bond, pair 1, pair 2, pair 3, right? So S has 1, P can hold up to 3. So the hybridized orbital would be sp3, and that's what F would be equal to for its hybridized orbital. All right, well, that's this lesson on hybridization using SF6. Please stay tuned for more exciting lessons, and I know you're having fun with hybridization like I do, and have an amazing day.